Hello, welcome, and thank you for joining us today for Leveling Up Environmental Sustainability, the latest NDSA levels of digital preservation revision. I am Elizabeth LeBeau from the University of Southern Mississippi and the Mississippi Digital Library, and I am honored to be joined today by Keith Pendergrass from Harvard Business School and Sibyl Schaefer from the University of California, San Diego. A little background on the levels of digital preservation. The levels is a resource to help digital preservation practitioners build or assess the technical components of their digital preservation program, divided into storage, integrity, control, metadata, and content areas. The matrix was originally created in 2013 and aimed to be updated every 5 years, the second version being released in 2019, along with additional supporting documentation and resources. The 5-year revision cycle that started this round that we're updating on began in the fall of 2024, and we are expected to release our final version in the spring of 2026. There are 2 groups that are dedicated to maintaining the levels of digital preservation, matrix and resources, and they are the levels of digital preservation steering group and the levels of digital preservation working group revisions. The steering group's main purpose, of course, is to plan and oversee the revisions every 5 years and organize the ongoing activities for the levels group, including open session hours and presentations at conferences. We additionally conduct outreach and promote the levels whenever possible. The Levels of Digital Preservation Working Group is dedicated to the specific work of revising the levels on a 5-year basis, so a very short, limited term. The scope of changes for this round of revisions is in contrast to the last round in 2019. While the 2019 process was very large, quite a bit of activity and highly collaborative, this round has been a far smaller working group and much more focused changes. The scope of the changes we've implemented this time have been based on community feedback gathered from open office hour sessions, as well as conference presentations, and of course, guidance from the steering committee. Our original concept for this revision was to edit our digital curation decision guide to include environmental sustainability components. However, we very quickly realized it would be better to build a new standalone environmental sustainability guide that can accompany the other levels resources. This revision's edits include minor edits to existing resources that acknowledge environmental sustainability, as well as redirecting to the new guide where needed.
Thanks, Elizabeth. So let's start at the beginning. What do we mean when we talk about environmental sustainability? So there are a lot of competing definitions, and to make it clear for the guide, we created a working definition. Environmentally sustainable digital preservation reflects practices that balance providing value to user communities with avoiding long-term depletion of natural resources and reducing the harm that preservation activities cause to humans, other species, and the natural world. And we built the purpose of the guide around this, to help organizations embed this broader type of sustainability, so thinking beyond carbon emissions, clean energy, or efficiency, into digital preservation decision-making when using the levels to measure and guide digital preservation strategy. But instead of providing detailed actions or step-by-step directions, we felt the guide would be more broadly applicable if we created a framework for environmentally sustainable decision-making. To do so, we surface broad core concepts and specific considerations for environmental sustainability decision points, which Sibyl will discuss in more detail in a few minutes. But before we get to that, we need to talk about how this fits in with our strong legacy of sustainability in digital preservation. So obviously, sustainability is nothing new for digital preservation. And in fact, we've long held sustainability in a general sense as a core requirement. that through our digital preservation programs, we seek to sustain the maintenance and care required to ensure digital materials remain accessible and usable over time. And we've built conceptual models like the three-legged stool of digital preservation and the digital preservation triad, which demonstrate that we must holistically sustain multiple elements for our digital preservation programs to operate effectively. But despite this holistic approach, we tend to treat environmental sustainability as separate from our core requirements. This separation negatively impacts the effectiveness of our programs as it doesn't reflect the often interconnected nature of the financial, organizational, environmental, ecological, and social issues that affect our organizations and our work. It also doesn't adequately address the importance of environmental sustainability to our work. Digital preservation relies on a stable society to enable our assessment, acquisition, and preservation efforts, as well as to ensure the engagement of our user communities. And society, in turn, needs a healthy biosphere that can support life. To remove this separation and add environmental sustainability as a core digital preservation requirement, we can use a model such as David Saunders' five-pillar sustainability model, in addition to preservation models like the three-legged stool and digital preservation triad, to balance considerations of environmental and ecological impacts within the context of digital preservation good practice, other sustainability concerns, and the needs of our current and future user communities. This is how we combine digital preservation fundamentals with holistic sustainability to inform our writing of the Environmental Sustainability Guide. And before I hand over to Sibyl to talk about core concepts and decision points, just a few words about the guide's scope. So as the levels focus on technology, the guide primarily looks at environmental sustainability through a technology lens. And while we know that curatorial appraisal and selection for preservation have significant environmental sustainability implications, they are out of scope for this guide because the levels are intended to be for those materials that your organization has already determined require preservation. Further, the guide includes considerations only for activities shown in the levels matrix and not for any supporting activities. And finally, while organizations are already experiencing the impacts of climate change augmented natural disasters and weather pattern changes, guidance on responding to and preparing for these impacts are out of scope for the guide. Instead, the guide focuses on reducing our profession's contributions to environmental and ecological harm.
So when we first started this work, we realized it was important to highlight what we're calling core concepts, which are guiding principles that are broadly relevant when assessing digital preservation actions from an environmental sustainability lens. They're meant to complement the environmental sustainability decision points, which I'll be talking about in a couple slides. And essentially, combining core concepts with specific decision points provides a framework for assessing and implementing environmentally sustainable choices. So, what are core concepts? I'm not going to go over each one that we list in the guide, but I'll highlight the most important ones. Sustainability decisions are not one size fits all and should be specific to your organizations. The decisions you make regarding sustainability should be based on your institution, the resources you have available, your policies, the content you steward, etc. Also, while measurement can help provide a baseline, which can inform and justify decision making, and serve as an effective advocacy tool, it's important to ensure that lack of measurement does not become a roadblock to making more sustainable choices. So, for example, in my place of work, we were evaluating whether we should reduce our fixity checking frequency from 45 to 90 days. We tried to get a baseline measurement of the energy usage at 45 days. Had a problem with our VM software in actually getting that measurement. And instead of waiting for a fix within the software itself, we decided to go ahead and implement the 90-day fixity checking frequency so that we could reduce our energy expenditure earlier rather than waiting. And lastly, the best place to start is to strategically identify the areas which will yield the most impact for the required effort. So for example, AV files are typically the file type with the largest per file storage requirements in a collection. Reevaluating and adjusting the storage or compute needs for these files will have a larger impact than reevaluating the similar needs for smaller files. The next section of the sustainability guide is the environmental sustainability decision points. And these decision points are structured around the functional areas of the levels. We identified 3 functional areas which have sustainability considerations: storage, integrity, and content. And within each area, the guide organizes the considerations around themes related to the levels matrix recommendations. I do want to emphasize that the decision points are not guidelines or recommendations. Rather, they should help frame your examination of the recommendations provided in the levels matrix. So the functional area of storage has 2 decision point themes. The first being number of copies and geographic locations. Having 2 full copies of the data in different locations is essential for redundancy and safeguarding against data loss. But when determining how many additional copies to maintain, you should focus on aligning the value of the preserved materials with the number of copies to avoid over duplication of lower value materials. The storage media type and storage system design recognizes the fact that different storage media types consume different amounts of energy during operation, and different storage system designs also vary in energy usage. For example, between online, nearline, and offline systems, online systems tend to consume more energy due to their continuous power draw, while nearline and offline storage are generally more efficient as they power on only when they require power only when active. The second functional area of integrity, the decision points around there, the integrity functional area, there's one major theme: integrity validation methods and checksum algorithm selection. And this is really recognizing that integrity verification processes can carry notable environmental costs from the energy use of the computational resources they require. So for example, as I mentioned before, one strategy here is to reduce the frequency of integrity checking. So you're reducing your energy usage for each integrity check, or yeah, overall, I should say. The last functional area we discuss is around content, and the theme we grouped our decision points around there is file format selection, migration, and normalization. And this section recommends evaluating things like file formats, compression methods, bit depth, and resolution, specifically for digitization projects. Do you need to digitize a film at 400 DPI, or I'm sorry, 4000 DPI, or is 2000 DPI sufficient? This section also recommends evaluating migration and normalization practices. So, do you bulk normalize everything as it enters your repository system, or is it sufficient to migrate when a format is no longer easily accessible? And with that, I will pass it back to Elizabeth.
Thank you, Sibyl. Our final takeaways and remaining timeline for our working group, just a few updates. So the Environmental Sustainability Guide is currently open for public comment. At this point, Keith will be pasting a link into the chat for everyone to view on your own time. Additionally, the minor edits that we have made to other levels resources are under review by our steering group. We expect this work to be concluded with our final release, which is dated for spring of 2026. Lastly, we absolutely would encourage you to join us for further discussions at the NDSA Levels Lunch session that happens tomorrow at this conference. Thank you very much for joining us today.